Welcome to this deep dive. Today we're taking a closer look at a pretty interesting approach for generating images that have specific text in them. And not just simple text, but across different languages, different fonts too.
Yeah, the source we're looking at is a technical report introducing this method called RepText.
Right, RepText. So what's the big problem they're trying to solve here? Text in images sounds straightforward, but it often isn't, is it?
No, it's actually quite a challenge for current text-to-image models. They really struggle to render text accurately.
Especially non-Latin scripts, I gather.
That's a big part of it. The way standard models encode language, for understanding meaning, it doesn't always translate well to visually drawing the characters, especially for diverse writing systems.
Okay. And the report mentions some existing ways people have tried to tackle this, like special encoders.
Yeah, people have tried using dedicated text encoders or adding extra modules, but these often come with downsides.
Like needing a lot of computing power.
That, or they might not give you much fine-grained control. Or they might be built on, let's say, older, less capable image generation models.
So RepText comes at it differently. What's the core idea?
Well, it's a bit counterintuitive, actually. They propose that maybe the model doesn't need to understand the text semantically to draw it well.
Huh. How does that work?
They use an analogy like how children learn to write. They often copy the shapes they imitate before they really grasp the meaning of the words.
Okay, interesting parallel. So it's about visual mimicry rather than understanding.
Yeah.
Let's dig into the RepText framework itself then. The paper says it's inspired by ControlNet.
Right, specifically things like glyph control and joy types, if you're familiar with those. It uses visual information as the main guide.
Visual information meaning what exactly?
It looks at the canny edges, basically the outlines of the text you want.
The shape.
The shape, yes, and also the position information where you want that text to appear in the image.
Got it. Canny edges and position.
These two pieces of visual information, the canny image and the position image, are encoded. They use a VAE encoder for this.
A VAE encoder that compresses the visual data, right?
Sort of, yeah. It learns a compact representation. This encoded info then goes into a special ControlNet branch.
And crucially, you're saying the actual text prompt, the words themselves, aren't directly fed in.
Exactly. The model isn't reading the text in the prompt to draw it, it's using the visual guides.
Okay, that makes the mimicry idea clearer.
Yeah.
The paper also talks a lot about glyph latent replication. Sounds important.
It is, yeah. It's one of their key innovations for getting that text accuracy up.
How does it work?
So normally, image generation starts with noise, right? Random static across the whole image space. With glyph latent replication, they don't start with noise in the areas where the text should be. Instead, they initialize those specific regions in the latent space.
The sort of hidden feature space.
Right. They initialize those text regions with a clean, noise-free representation of the glyph shapes. So the text starts out clean while the background starts noisy.
Pretty much. This gives the text rendering a huge head start in terms of accuracy. And a neat side effect is that it makes specifying the text color much simpler, apparently. You can bake it into that initial latent representation.
Makes sense. Accuracy is clearly a big focus. They also use something called a text perceptual loss during training. How does that help?
Well, during training, you have the usual loss function guiding the image generation, the diffusion loss.
Standard stuff.
Right. But they add this text perceptual loss. It basically uses an OCR model.
Optical character recognition. To read text in images?
Yes, they use PPOCRv3 specifically. This OCR model looks at the text the generator creates and compares how recognizable it is to the ground truth text.
So it's like having a proofreader check the output during training.
That's a good way to put it. It pushes the model to generate text that isn't just visually plausible, but actually legible according to the OCR. Okay, now what about protecting the rest of the image? If you're focusing controls so much on the text, does it mess up the background? They mention regional masking.
Yeah, that's important. At the inference stage, when you're actually generating the final image, they apply a mask.
A mask just over the text areas.
Correct. This mask ensures that the control signals from the ControlNet branch, the ones specific to the text outlines and position, only affect those designated text regions.
So the background stays clean and isn't distorted by the text instructions.
Right. It prevents unwanted artifacts or style bleeding from the text into the rest of the scene.
Let's talk about the multilingual aspect. The examples show Chinese, Korean, Japanese, Russian. How does it handle all these different scripts if it's not understanding the language?
It comes back to that glyph replication idea because it's
Yeah.
fundamentally working with the shapes, the canny edges. It doesn't really matter what language those shapes represent.
As long as it gets the visual input for the characters.
Exactly. Provide the canny edges and position for Chinese characters, Cyrillic letters, whatever, and it uses that visual information to render them. This sidesteps the big challenge many models have with non-Latin text encoding.
And font control works similarly, I assume, using the canny edges of the desired font.
Precisely. If you want a specific typeface, you generate the canny edge map for your text rendered in that font and feed that into RepText as the control signal.
That offers quite a bit of control. The report also mentions compatibility with other tools, like LoRa's and other control nets. Why is that significant?
Well, it means RepText isn't just a standalone thing. LoRa's, these small add-on models, let you inject specific styles, right? Like making something look like a film portrait or wool yarn.
Mm-hmm.
And ControlNets add other kinds of spatial control. IP adapter lets you use image prompts. The fact that RepText can work alongside these
Means you can combine the precise text rendering with all sorts of other stylistic or compositional controls from the community?
yes. It slots into existing workflows, which is a big plus for usability. You could have specific text on a character generated using an IP adapter styled with a LoRaWA.
Okay. They also did ablation studies, right?
Yeah.
Testing which parts of their system made the biggest difference. What did those show?
They found a few key things. First, using both canny edges and position information together gave the best results, better than just one or the other.
Makes sense. You need shape and location.
Right. They also confirmed that the glyph latent initialization starting the text areas clean was really crucial for typographic accuracy and for enabling that easier color control.
And the regional masking.
Also confirmed to be important. It significantly improved the background quality by stopping the text controls from interfering.
No system is perfect, though. What limitations did the researchers acknowledge?
They pointed out a few things. Sometimes the text can look a bit pasted on, like it's not perfectly integrated into the scene's lighting or texture.
Just harmony, yeah.
Disharmony, that's the word they used. Also, it can struggle with very complex characters, lots of fine strokes, or really small text sizes. Accuracy can drop there.
Yeah.
Occasionally, it might even generate some extra kind of meaningless text artifacts. And direct control via the text prompt over things like the text material or very precise color matching or perspective distortion isn't really there yet.
So room for improvement.
Yeah.
What about future work? Where might this research go next?
They mentioned exploring ways to help monolingual models handle multiple languages more efficiently, perhaps without needing the full visual input for every script, maybe low-cost adaptations.
Interesting.
And they also pointed towards techniques like metaquery, which sounds like using lightweight connectors to tap into the understanding of multimodal large language models, MLLMs, to potentially improve image generation, including text.
So potentially bridging the gap back towards some level of understanding, but maybe in a more targeted way.
Possibly, yeah.
Uh.
It's about finding efficient ways to enhance control and quality.
Okay, so to recap, RepText is really this novel take on text and image generation, focusing on replicating the look, the glyphs, rather than deep semantic understanding.
That's the core idea. And the main wins seem to be the controllability font, position, and its ability to handle diverse languages without necessarily retraining the base model extensively for each one.
But with current limitations around perfect scene integration, complex details, and some aspects of direct control.
Right. Those are the areas where research is likely to continue. How to get that seamless integration and handle trickier cases.
It really makes you think, though, doesn't it? This idea that visual creation, at least in some aspects, might not require the kind of deep understanding we often assume. Focusing on the surface representation can be surprisingly powerful.
It's a fascinating principle being tested here, and you wonder where else that kind of replication over understanding approach might prove useful in AI.